In our previous podcast, we looked at multiplying exponential equations of the type here in problems 1 and 2. In this podcast, we'll review that briefly, but we're going to concentrate more on evaluating. Over here on the right, I've given you a list of variables with values for the variables. I'm just repeating them because it's really not important what the variable name is. So both A and P, for instance, if A shows up in an expression or P, I'll use 3.2 for that value. If B or Q shows up, I'll use negative 2.5 for that value, etc. Let's go ahead and start with the first example. This is asking you first to multiply and then evaluate. Now to multiply, misspelled evaluate there, that should be a T. Now to multiply, you just need to understand the notation. When a number like 2xy is sitting beside a bracket, and there's no symbol between the number and the bracket, then it means multiplication. So this means 2xy times x squared y squared. However, when two letters are sitting beside each other, or a number or letter with no symbol, it also means times. So there's a times here, there's a times here, and there's a times here. Now multiplication is what we call commutative. That is, the order in which you do it doesn't matter. So I'm going to rearrange the terms. I'll put my x's together, and I'll have x squared, and I'll put my y's together, y squared, and x times x times x is x cubed, and the same for y, so this is just simply 2x cubed y cubed. So now to evaluate the expression, and what I'm going to do is I'm going to evaluate it once unsimplified and once simplified. If I get the same values both ways, then I figure that my simplified version here is the same as my original version. So let's first evaluate the original version, and we're going to evaluate by two different methods. The first method I call empty holes. In this method, we're just going to write down the original expression. Each time we come to a variable, we're going to leave an empty hole in its place, but other than that, we're going to try our best to duplicate exactly what the original expression was. In the second method, we will assign values to variables, and then we will write the original expression pretty much as it was originally. So let's begin with empty holes. Each time I get to a variable, I'm going to put an empty hole in its place, and I'm going to do the unsimplified version, the original problem with the empty holes. So instead of writing 2x, I'll write 2 empty hole. Instead of y, another empty hole. Then I'll open bracket. Now here I have x squared, so here I'll put empty hole squared. And next y squared, so another empty hole, this one will be for y squared, and then close the bracket. I then plug the appropriate number into each empty hole. This empty hole and this empty hole stood for x, so in those two empty holes I'll put negative 3.6. The other two empty holes stood for y, so in those I'll put 2.7, and there's the expression that I have to evaluate. So I'm going to put that into my calculator, and my calculator is invisible down here. Let's see how I can handle that. Had to figure out how to bring that calculator image up there for a second. The calculator's not on, so I'll hit the on button. Looks like I have to double click it. There we go. And I'm going to just type in exactly what is on my paper. I'm going to put that exact thing into my calculator. Now notice when I write on the screen, the calculator disappears, so I have to bring it back. So I want 2 open brackets. So I come down here, 2 open bracket. Negative 3.6, negative sign 3.6, close bracket. Then I want open bracket 2.7, close bracket. open bracket 2.7 close bracket. Okay, the next thing is an open bracket and then another open bracket, negative 3.6 close bracket. So open bracket, negative 3.6 close bracket. Now that's right here, and that bracket gets squared, so I have to make sure I square that, and the squaring key is right here on my calculator. And I don't need the blue, the key is the square, so I just hit the square and it puts a square on that bracket. Now I need open bracket 2.7 close bracket squared. Open 2.7 close squared again, and then behind the squared there's another closed bracket. Now it's a good idea when you're putting things into your calculator to make sure your opens and close matches. So I'm going to count them here. I have 1 0 1 0 1 2 1 2 1 0. So it looks like the number of open and closed brackets do correspond. I make sure I get the right numbers in. Negative 3.6, 2.7, everything looks good. I hit enter and I get this long answer, negative 1.8366. And I notice down here at the back E3. Now that's real important. That means that this number has been put in scientific notation and it is times 10 to the power 3. So what that means is if I was writing this in normal form, that decimal would be between the two sixes. It would be 3 places over. And I think I will write a normal form answer here. Notice if I consider the 2 exact, but I consider the 2-digit numbers approximate, then I would get a 2-digit answer. The 2-digit answer would only have the 1 and the 8. So if I'm going to move that decimal over 3 places, that's going to put the 8 in the thousands position. If the decimal were right here, right here, the 8 would be in the thousands position. So I'm going to write for my answer negative 1 8. Then to make sure my 8 is in the thousands position, I'm going to put 0 0. Now let's see the difference between that and programming the home screen. In programming the home screen, I begin by assigning values to numbers. So what I'm going to put into my calculator is, since this is going to use x and y, and I'm going to use negative 3.6 for x, I'm going to put into my calculator negative 3.6 store to x. And I'll show you how to do that in a second. And then to show that I've finished doing what I set out to do, I'm going to put a colon there. Then I'm also using 2.7 for y, so I'm going to write 2.7 store to y and put a colon there, and that says I've completed another step. Now here's the really cool part about programming the home screen. Once you've assigned values to your variables, you simply record exactly the expression that you want to evaluate. I told you we were going to evaluate this expression once before we simplified it, like this, and then we were going to evaluate it again after we simplified it. So here I'm going to evaluate it, and here's all I have to do. 2x to the power 3 y to the power, whoops, that's also 3. Y to the power, oops, keep messing up, y to the power 3. See, all I do is put in just exactly that simplified form. Now I could have put in the original form too. The 2xy, x squared, y squared, I could have put that y here. Either way, it would evaluate it. What I want to know is, when I round and everything, do I still have negative 1800? If I do, then this simplification is probably correct, isn't it? So let's go ahead and give that a try. I'll bring my calculator back up. I'll do negative 3.6 store x, so I go to the negative sign, 3.6. Now the store key is down here near the bottom on the left side. It has a little arrow associated with it, and when you hit the key it shows a little arrow. And then the easiest way to get x here is the xt theta key. So I'll hit xt theta, And then to get a colon on the TI-82, a colon is in blue above the period. So what I would have to do to get a colon would hit the blue key and then the period key. And that tells the calculator I've completed one step storing negative 3.6 into X. I also wanted 2.7 into Y, so I'll go ahead and do that. I'll hit the store key, but it's not as easy to get a Y. I don't have a big key for a Y. So I come down here looking for a Y, and I find my Y right here above the 1. And my Y is in gray. So I hit the gray key and then the 1. And that prints a Y. And remember, the colon was in blue above the period, so I hit blue, period, and that sets up another colon. Now I need to put in my 2x cubed y cubed, and I want to caution you. Different calculators handle symbols in different ways, and I was experimenting with this calculator earlier, and I found that when you write the 3 by the y, it puts a bracket around them and tries to join them. Now with that knowledge, I'm going to say times. That's certainly okay because the x cubed is times the y cubed. But that'll separate those two and the calculator won't try to put them together. So it's always better either to put a times there, or another option is to put the 3 in a bracket, and that will separate the 3 from the y also, at least on a TI-82. You try your calculator and see what works. So I'm going to just put that in there now. 2x cubed times y cubed. 2x to the power 3 times, remember y was right above the 1 key, alpha y to the power 3. I'll complete that with a colon. That's probably not necessary, but I'm going to do it. Blue period. And now I'm ready to evaluate, so I hit enter. And there's that same number that we got before. So that tells you that when we simplified 2xy times x squared y squared, and we got 2x cubed y cubed, we did it correctly because we got exactly the same number using 2x cubed y cubed as we did when we used the original form 2xy x squared y squared. I would round it, of course, in the same way. If you want to keep the E notation, you still have to round to 2 digits if you're considering the 3.6 and the 2.7 to be your only approximate number. So if you want to round to E notation using the 2 digits, you would just put negative 1.8 E3. That moves the decimal 3 places to the right. So this answer is correct and this answer is correct. This is called the normal form, and this is called the scientific notation. Okay? Let's try another one. Again, the multiplication is not very complicated. We've covered that in previous podcasts. What we're concentrating on here is the evaluation. But from here on out, I'm just going to use programming the home screen to evaluate. I think that's a very, very powerful method. So let's try it. This next one is 2 times negative 3b times 2b squared minus b. Now some people try to distribute the negative 2 to the 2 to the negative 3 and then the 2 to the b. You can't do that. Notice that there's no plus or minus between the 3 and the b. That means that in this bracket is only one term. And when there's only one term, you can only use this outer number once. So I'm going to use it to multiply the 3. So I get negative 6b. I didn't do anything here, so that's still 2b squared minus b. Now notice the difference between the second bracket and the first bracket. Here the 3 and the b were joined together by times. That made it all one term. But here there's a minus between them, so that's 2 terms. That means I get to use this outer number, the negative 6b, twice. I use it once on the first term, and then I use it again on the second term. So I'll get negative 6b times 2b squared, which will be negative 12b cubed, and then negative 6b times negative b, which will be positive 6b squared. And that's what I want to evaluate. This time I'll be evaluating it for b, and b is negative 2.5 as you see here in my chart. So the first thing I'll do is I'll say negative 2.5 store to b. The calculator won't let me make a small b, so I'll just make a big one. Then I'll put a colon, and then all I'll have to put is negative 12 b to the power 3 plus 6 b squared. I don't use the power 2 because I have a squared key on the calculator. Now to do that, I'll bring my calculator up. Let me clear the screen because it's starting to get too cluttered. And I start off with a negative 2.5, store 2, and now b, where would that be? Well, look up here at the top. There's starts off ABC. B is above the matrix key right here. And again, the B is in gray. So I hit gray or alpha matrix, and that forms a B, and then I want to put a colon, so second period. Now all I have to do is put in the formula. And notice that the B is not beside another numbers, but anyway, I've already got an operating sign in there. I've got the plus symbol. So even if it was, it wouldn't hurt anything. So I'll put that in, negative 12b to the power 3, negative 12. For b again, I'll hit alpha matrix to the power 3 plus 6. For b again, alpha matrix again, and for the squared, my x squared key. So there I've got it, negative 12b cubed plus 6b squared, negative 12b cubed plus 6b squared. So I've got it in correctly. I hit a colon, which is second period, telling the calculator I've finished that step, and now I hit enter. And I get the value 2.25E2. Now E, remember, means times 10 to the power. So that's 2.25 times 10 to the power 2, which means I moved my decimal 2 places to the right. So in normal form, my answer would be 225. But again, if I'm going to consider this to be a 2 significant digit approximate number with all the constants in the formula being perfect numbers, then I would have to round that 225, because this just, if I move that decimal 2 places to the right, that's just a simple 225. I'd have to round that to 2 significant digits. So if I'm using approximate number rules when I'm doing this, 2 significant digits counting from the left, there'd be 1 and 2. So to round, I'd go the next one over. Since it's 5 or more, I'd round up. So my digits would be 2 and 3. However, the digit I was rounding on was a 10, and if I say 23, I'm saying it's a 1, so I have to add a 0 to show that it's in the tens position, and that makes it 230. Now, suppose I said, oh, did I use B? I meant to use Y in there. I didn't mean for you to plug in whatever B is, negative 2.5, I meant for you to plug in positive 2.7. Well, that's really an easy change to make. All I'd have to do is come in here and change my B to 2.7. The calculator doesn't care whether I'm calling it a Y or a B. And that's a pretty easy change to make. Let me show you how to do that. If I want to change it, I have to get up here to where it says negative 2.5, and I have to get rid of the negative and put in 2.7. When I try to arrow up, the cursor won't go up. You see, I'm pressing my arrow key here, and the cursor just won't go up. So what I do is I recopy it by going second, enter. And it recopies it, and notice it moved the cursor up. So I move it up a little more. And I want this to be the number 2.7, so here's what I'm going to do. I'll put that cursor right over the negative sign. I don't want a negative, so I'll just put 2.70, which numerically is the same as 2.7, and I'll hit enter again. And there's my new value, negative 1.9E2. Again, if I'm rounding that to 2 significant digits, it would be negative 190. So you can see how powerful programming the home screen is, especially if you're going to be changing the values of the variables. The changes are so easy to make. You just have to make them in one spot. If I was using an empty holds, I'd have to change the variable here and here and here each time. Well, the more changes you make, the more chances of making an error. So not only is programming the home screen easier, but it's also a safer way to go. We have one more to do here. In this problem, you see a part of it looks like the FOIL, and then there's another number multiplied. If you're good at the FOIL, I would just FOIL this. If you're not good at the FOIL, then you distribute twice. I'm not going to use the B yet. I'm going to say B, or P rather, times something. Now to get the something, I'm going to pretend for just a second that I don't know how to FOIL. And for those who don't know how to FOIL, I'm going to take this bracket and I'm going to distribute it to the first term and to the second term. Here's what that looks like. Bracket 5p minus 2q times p plus bracket 5p minus 2q times q. Whoops, times 8q. So now I've still got two terms inside the major bracket, now separated by this plus sign, and notice that this p is now multiplying a bracket, and in the bracket is two terms. So I can now distribute this p back this way to the two terms in its bracket. So I'm not going to do anything with the outer p, I'm going to just leave that alone. P times 5p is 5p squared. P times negative 2q, negative 2pq, plus 8q times 5p, 40pq, and then minus 8q times 2q, 16q. Now, before I can proceed, got too many brackets there. Before I can proceed, I have to remove the inner brackets and combine these two PQ terms. So to remove the inner brackets, I'll just distribute ones. 1 times 5p squared is 5p squared. 1 times negative 2pq is negative 2pq. Here's another 1. 1 times 40pq is plus 40pq. And 1 times negative 16q is negative 16q. And now I have done this part of the problem. I have multiplied 5p minus 2q times p plus 8q. Now again, let me emphasize, if you know how to FOIL, just FOIL it. These are both PQ terms, so I'm going to put them together. So I get p times 5 times 5p squared, and then the negative 2pq and the plus 40pq give you plus 38pq minus 16. Ooh, wait a minute. And that was an 8q times a 2q, so that was a 16q squared. So let's make sure we get the squared in there. And now I'm ready to multiply by p, and notice that inside the big bracket there are three terms. So I'll be multiplying 3 by this term, by p by this term, by this term, and by this term. 3 times I will use it. So I will get 5p cubed plus 38p squared q minus 16 pq squared. Now to evaluate that for p and q, notice up here at the top, p is 3.2 and q is negative 2.5. So I'll bring up my calculator. I'll move it up a little. Let me make a little note here. P is 3.2 and Q is negative 2.5, and by making that note I can now drag my calculator up here so that it's out of the way of the bottom. Now, a lot of times on your test, I'll say show screen. When you see that on a test, it means show what is on the calculator screen. So I'm going to put these numbers into P and Q. So I'll start off 3.2 store P colon negative 2.5 store to Q colon. Then I'll put in my expression right there, and then I'll say enter. So here we go. The calculator's turned off, so I turn it back on with a double click. Clear the screen because I've got a lot of stuff to put in it. 3.2 store to P, 3.2 store key. I look for the P on my calculator, it's above the 8, so I hit alpha 8, then a colon, second period, and then negative 2.5 store Q, negative 2.5 store to alpha 9 this time, since Q comes right after P, and again a colon, second colon, and that gets me through the part that I've written here, and now all I have to put in is the formula. So I put in 5, and then P was alpha 8, so alpha 8, and then that was cubed, so I'll hit to the power 3, and then plus 38 P squared Q, 38, P again was alpha 8 squared, and Q was alpha 9. So 38 P squared Q, and then I want plus or minus 16 PQ squared. 16 alpha 8 for P, alpha 9 for Q squared. And of course, the only thing that squares is the Q. It does not square the P. And then I put in a colon, second period. And there you have what it looks like on your calculator. 3.2 store to P, negative 2.5 store to Q, 5P cubed plus 38P squared Q minus 16PQ squared. I hit enter. And in one little click, there's the answer. It's an E3. So now if I move my decimal, get my calculator back up there. If I move my decimal, my numbers are negative 1129. Now, again, if I'm going to round to 2 digits, all I want is the negative 11. But if I was doing it in normal form, it would be negative 1129. And if I'm rounding to 2 digits, since the third digit over is less than 5, I would just get the, I guess I have to click up a little bit. I would just get the negative 11, but I have to show that this 1 is in the thousands position. So I put 2 zeros there. And that would be your answer, and that completes the podcast.